We humans have gone on geographical expeditions, reached the heavens and space. In fact, we carried the flag of science almost every way by diving into the Mariana Trench, the deepest place on Earth with about 11 kilometers. However, we know less about the oceans that cover 70% of our planet than about the stars in the sky. Despite the fact that we have drilled so many oil wells on the seabed and laid thousands of kilometers of underwater cables between continents for the internet, it is great curiosity why we know so little about the oceans. And it is the time to satisfy this curiosity decently. What does the ocean floor look like? They say the sky is the final frontier, but the real and explored space is the world's oceans. As a matter of fact, according to the report of the US National Oceanic and Atmospheric Administration, we have not yet explored 95% of the ocean floor. So much so that we even know the surface of Mars better than the oceans. Gravity test for the oceans. In 2014, scientists created the most up-to-date and detailed map of the oceans using satellites orbiting the Earth. They used the satellites equipped with altimeter devices powered by radar waves to accurately scan the ocean floor. Despite the mass of water, the depth of which in places exceeds 4 kilometers. The altimeters measure very decisively the distance between the satellite to which it attached and the water surface directly below it. So much so that canyons and mountain chains on the ocean floor form dense concentrations of matter. There also slightly increase the gravity in the part of the Earth. Small difference in the local gravity intensity lead to change in sea level. For example, the sea surface above an underwater mountain chain can be lower or higher than the average sea level. Since such peaks and elevations on the sea surface are permanent, they can be distinguished from standard ocean waves and currents. What is under the ocean floor? Of course, there is a thick layer of rock, but it is not an ordinary layer of rock. Microbes also live at the bottom of the seas. In 2015, geologists went to the coast of Japan and drilled a borehole at the depth of 2 kilometers on the seabed and found bacteria living in the Earth's crust at the depth. Yes, life is not as common under the ocean floor as in the seas, but we found that between 10 and 10,000 microorganisms per cubic centimeter live inside the thick sediments. Despite the high pressure and temperature 2 kilometers below the ocean floor, some microbes have gained a foothold in the rocks. Moreover, when we analyzed the genes of these microbes, we found that they are related to microorganisms living in humus soil, rather than microbes living in mud on the seabed. So much so that these extremophiles living in extreme conditions may be descendants of bacteria that lived in soil 20 million years ago. So, how can we explain the kinship bond? With the sinking of the land, although the sinking of entire continents takes place of 1 billion years, it also partially takes place the sea level change according to the average temperature of the Earth. The seas can rise and fall, which allows coastal areas to remain underwater. Of course, there are also microbes that are poured into the sea by rivers, and they also accumulate underground along with the sediments. Those strange bubbles of water with methane gas create oil, and a high percentage of salt are rising from the ocean floor. Oil companies are also looking for these pockets to extract natural gas from the sea and drill wells into the mud underneath. Some water bubbles found in the Gulf of Mexico contain 4 times more salt than the sea. Although the salt water that becomes heavier cannot rise the ocean surface, it forms a cushion just above the seabed, and submarines can swim on these bubbles just like on the lake surface. Although such bubbles are poisonous, the sea creatures halophilic that is, salt-loving bacteria, live in them. My story sounds coming from the oceans. The USA National Oceanic and Atmospheric Administration, the density of ocean water temperature, currents, and the direction of the hydrophone to measure the chemical composition, because it uses the microphones so that they are found in the speed of sound waves depends on the density of the media. In short, hydrophone networks allow us to measure the movement of the oceans in semi-real time. However, such scientific uses are usually limited. NOAA often uses water microphones to listen to the sound of boats, engines, detect marine earthquakes, and monitor whale calls. As a result, it also happens that their underwater microphones hear sounds, the cause of which cannot be determined. As a matter of fact, in 1997, they heard a very high and low frequency sound, and scientists called it bloop. The bloop was heard by two different water microphones, which are 5,000 kilometers apart from each other. Fortunately, we were a little luckier this time and we were able to identify the true source of bloop. These sound waves, which had to be very violent to be heard by two microphones at such a distance, were caused by an ice earthquake that took place on the Antarctic coast. Red alert for the oceans. However, ocean scientists also heard the sound of boop this time, and that was a high-frequency sound that was getting louder and louder, like the red alert sound in the Star Trek movies. Of course, it's extremely normal to find unidentified floating sounds with metal microphones because one-time sounds can have undetermined causes. The problem is that we have been hearing the boop sound coming from under the water since 1991. Moreover, we hear this sound that arises in the waters of the Great Ocean only in certain months of the year, seasonally. Especially in the spring it begins to be heard and stops in the fall, which is where geologists rather than oceanologists come into play. Perhaps these sounds come from volcanoes and volcanic cracks on the seabed, the giant, dark and deep oceans that make up 70% of the world today contain unknowns greater than space for humanity. But one day we will come there, and we will be able to solve the unanswered questions about the oceans. But do you know that there is also a global underground ocean on Earth? In short, that Jules Verne's novel Journey to the Center of the Earth turned out to be true in a sense and in part. Aside from the subsurface ocean, there are ocean worlds in the solar system that contain more water than the Earth and perhaps host life.